Gaurav Moda. I lead the energy practice for EY in India. I have with me Mr. Kush Singh. He's the sector head for power for Calcutta Energy Supply Corporation, CESC, with a long stint back at NTPC, SR, Adani, and now at CESC. We also have with us Mr. N. Venu. He's the MD and CEO for Hitachi Energy for India and South Asia market. Welcome, Venu.
Thank you.
The conversation that we'll be having today is around the future clean energy power transmission and distribution pathways. In context of the broader India Energy Week, which is focusing heavily on energy transition, in that context, I think it's important to understand and get perspectives from our co-panelists on how energy transition is happening all over the world, how it's impacting India, and then we delve deeper into, particularly in transmission, how clean energy is integrating in terms of global learnings and in learnings for India market. So I think with that, let me invite Kush, your early thoughts on the broader energy transition happening globally and in the country.
Thank you. Thank you. Good morning, everyone. The whole world is towards energy transition, moving towards green, moving away from fossil fuel. Of course, India will have to have a balance between fossil fuel as well as green, which will come into details when we go along the discussion. As far as the capacity additions which are required to be done, the augmentations required to be done in the whole process of green transition, speakers from in the last 2 days must have elaborated. So I won't go into much of statistics there. I would go more into the kind of initiatives that are required, the kind of initiatives the government has taken, the kind of policy decisions the government has taken towards its energy transition, so that India gets secured of energy, both consistent and sustainable. See, we are a den of coal. Thermal power has been the backbone of our power economy, but now we are transitioning. So in order to adapt to the time and make sure that all our resources are fully utilized, the first great step the government of India took was towards coal gasification. And all the chemicals downstream, everything related to food security, which is totally subsidized today in the country, is all from natural gas. The source is natural gas, which comes to India at a big price. This whole transition and those initiatives towards coal gasification, using the high ash coal which we have, which maybe 15 years down the line, nobody would even think of taking it out from the ground. Taking it out, gasifying it, and when you gasify this coal, our high ash coal, the syngas produced is almost 1/4 of the price of the syngas which you produce by steam formation of natural gas. So then downstream chemicals, that is ammonia, urea, DME, acetic acid, whatever, all the downstream chemicals, the price goes down proportionately. And this will become one of the key factors of increasing GDP. Why? Because first, it will reduce your import of natural gas, maybe 10 years down the line, make it zero. It will enhance your exports of chemicals or energy molecules. Today, India is the largest importer of energy. We have never dreamt of exporting energy. But tomorrow, by virtue of these downstream chemicals coming out of coal gasification and syngas out of coal gasification, we will start exporting energy. So exports would increase. The subsidies will come down to zero, thereby enhancing the GDP level. This is one aspect. The other is more and more of renewable power coming into the field. Solar, wind. We have a huge potential of wind. We have a huge potential of solar. We have no paucity of land. We have no dearth of water bodies. We have no dearth of sea coastline where we can have offshore winds. We can have floating solar, we can have ground mounted solar, rooftop solar. You say whatever we have. We have good geotechnical sites, favorable sites which can provide pump storage. So all these put together, we have a very fine, very nice, strong, renewable resource there in India, by virtue of which we are growing. We could never imagine. Today we are at 100 gigawatt of renewable. It was a massive achievement. We have to do much more. We will become 350 gigawatt by under 2 years. But the base load will always be a blend of thermal and nuclear. Now, how does that nuclear come into the perspective? Recently, in the budget speech, finance minister announced that we'll go for small modular nuclear reactors, wherein there will be a speeding process of policy amendment, which is allowing private participation, and the amendment in the Civil Liability Act. Now, I just give this house a glimpse of what we are doing with respect to solar, with respect to small modular nuclear reactor, which is required for the country. The small modular nuclear reactor which India today is working on, as well as we as a group working on with foreign technology, is a thorium molten salt based reactor. Now you may ask me a question, why thorium? See, when we did the Pokhran test, we had only two nuclear plants at that point of time, Tarapur 1 and 2, which had GE supplied boiling water reactors, which were based out of enriched uranium from USA. The day we did our Pokhran test, we were shunned by the world, discarded, set aside. The fuel stopped. Tarapur 1 and 2 stopped. But our nuclear mission, the missionaries in the whole nuclear program were so aggressive, we went to Canada because we had to adapt with time. The only uranium we have in India is natural uranium. If you use natural uranium in the fission process, you need moderator as heavy water. The only country which had heavy water based reactor design was Canada. We went to Canada, got the CANDU reactors, came back to India, set up reactors. Since then, all the nuclear reactors set up in India have been CANDU reactors based on heavy water, natural uranium. Till Kudamkulam, where the Russians came in, they brought the VVR reactors and then based on enriched uranium. But in this scenario, the reactor is in surveillance of the technology provider, the reactor is in surveillance of the fuel provider. So there's no level of independence which you have with respect to a plant existing in your own country. So the first philosophy is made in India, Atmanirbhar Bharat. So when you do that, when you work on that philosophy, we have the largest reserve of thorium in the world. If you go to Kerala, you're walking on thorium. So the reactor will be based on thorium molten salt, thorium uranium fluoride, thorium uranium chlorate. Heavy water would be the moderator. The reactor will come in two orders, 10 megawatt electrical and 30 megawatt electrical. A 10 megawatt electrical small modular reactor, nuclear reactor, comes in a 20 feet container. And a 30 megawatt electrical modular reactor comes in a 40 feet container. Absolutely modular, plug and play. And the cost of power, see, nuclear is called a green power. So the cost of power is less than 2 rupees a kilowatt hour. Today, if you think of getting round the clock power, it will be a blend of solar, wind, pump storage, battery storage, and all other forms, all blended together. The cost is not coming below 7.5 to 8 rupees per kilowatt hour. And that too for not 24 hours. They'll say we'll have 85% availability, some 60% in a 15-minute slot, which you cannot afford if this round-the-clock power, renewable power, is feeding an ammonia synthesizer or it is feeding a hydrogen electrolyzer. No. You cannot afford that. So, green power coming out of nuclear power, a small modular reactor, is the answer to round-the-clock renewable power at the cheapest price. Now, when you get round-the-clock renewable power below 2 rupees a kilowatt hour, you set up a hydrogen electrolyzer. And which electrolyzer would you choose? The one which has the best current efficiency, an SOEC, because it uses steam. It reduces steam. So, you have steam at 700, 800 degrees centigrade from the SMR. You choose an SOEC, you produce green hydrogen. From green hydrogen, green ammonia, green methanol, DME, acetic acid, blah, blah, blah. So downstream chemicals. And then you start exporting them. You get hydrogen at below $1 a kg. Your job is done. You rule the world. You're on a different orbit altogether.
So problem solved. Huh?
Yeah.
SMR
SMR.
is an
So
interesting.
yeah, and for big nuclear reactors, big companies like L&T, Adani, Reliance, they are merging. They are having a JV with NPCL. Well, they set a big reactor. Big reactors, you have huge land requirement. There are exclusion zone constraints. There are sterile zone constraints. Whereas for an SMR, the boundary wall of the plant is the exclusion zone, and the reactors can be stacked one upon the other. So if I were to set up a plant to export 1 million ton of ammonia, green ammonia, I'll need about 150,000 tons of hydrogen. I set up a 1.3 gigawatt SMR, maybe 40 reactors of 30 megawatt size each, and plug it with 2 units of 800 megawatt turbine generator, and the show is done. The land requirement is hardly 150 acres. So this is the call of the time. And just to inform the House, there's a nodal agency in India called IYNS, Indian Youth Nuclear Society. They are developing this 10 megawatt electrical nuclear reactor. The Honorable Prime Minister of India has named the nuclear reactor as SUKAM. SUKAM is Swachalit, self-dependent, Uttarankit, U for Uttarankit, that is innovative, K for Kendrak. Kendrak means nuclear. It comes out of nuclear vibhajan, that is nuclear fission. So K for Kendrak and M is micro, Sukshma. So the reactor is called Sukam. And the pilot reactor will be in place by 29, designed, fully established, made critical, and then by 2030 it will become commercial. So the business houses who wish to get into green hydrogen, they will adopt this SMRs. And for the base load power, that is blend of coal and nuclear, the larger nuclear plants will be established. But they have their own gestation period, they have their own cost factor. So this will be the key to India's power plant configuration and power divide, so as to take the GDP to a different level altogether.
I think very interesting perspectives, Kush, and sets the stage for how power generation can be different from just conventional coal. Interesting, you spoke about SMR because, in context of clean energy transmission, a key requirement also is to service data centers
Absolutely.
and high generation requirements for EV. So, in that context, SMRs become important to be placed in select locations and build up on that. We'll come to a little more on that, but Venu, coming to you, like I said, initially we're starting the panel from broader energy transition perspective. What are your views from the global world? And also, if you can go a little particular into how Hitachi Energy is contributing to that.
Yeah.
And then we'll come to the transmission aspects as well.
Okay.
Yeah.
Thank you very much, Gaurav. First of all, very good morning to all of you. I do understand the Delhi traffic boost, so that's the reason people are coming in, so fully understand. So it's a pleasure to be here and pleasure to be part of the great panel here. And we are Hitachi Energy and we are part of ABB previously, and as part of acquisition, then we moved into Hitachi Energy in that. So basically, if you ask you what we do, we in a very very layman language. So we are the bridge between the generation and the consumption. Okay, whatever way you generate, whether it is a fossil, renewable, nuclear, hydro, anything, and then you transmit, you distribute, and then consumption, all the industries, transportation, you name anywhere, and that's where all our technologies play a major role in that. And we are a global leader, pioneering technology leader, and many of the technologies we use has been invented by us many years back. Just to give you one example of our invention is HVDC technology, which is very much required to bulk transfer the power over a long distances, like a 6,000 megawatt in Raigad to Pugalur we did for our customers in PGCL, over 2,000 kilometers, 6,000 megawatt of power will transfer. That kind of technology we invented 70 years back in that. So if I come back to the bigger picture on the energy transition standpoint, I think We have actually in the year 2016, in the first time we have, as part of SIGRE keynotes speech. So that time, we talked about the power system of the future, because we have seen the energy transition is coming towards more, renewable penetration is taking shape. A lot of, decentralized generation. Okay, as used to be what we have seen, pithead power plants and over long distances transmitting the generated thing. And we also seen that, going forward, a lot of electrification, the new forms of electrification is coming in, whether it is the transport sector, whether it is, some of the industrial processes being electrified. So those are the things we have seen. So we just bucketed the two things. The power system of the future should be possible, should be capable of integrating any amount of any source of a generation from anywhere, whether it is a centralized or decentralized, you're able to link it, connect it to the grid. That's the number one thing in what we are looking into. And the second one is it should be capable of electrifying anything and everything. You talk about electrifying the transport sector, you talk about electrifying the industrial processes, or talk about electrifying the household things. That's where is the thing in that. So this whole complexity arising out of these energy transition, you need to have a very flexible systems compared to what we have seen in that. So the power system has been there and it will be there, but today we see a huge shift in that, and that's where the energy transition has actually accelerated, I would say, post COVID, and also after the Russia-Ukraine war. There's a lot of focus from the planning governments and other stakeholders, talking about the energy security, energy, and a lot of things have come on the localizing it and further challenges of this renewable, etc. So that has really pushed the demand, and we are now talking about the connecting countries, connecting the nations, and the technologies are available to take care of all these things. So energy transition, as a thing, it is not a one pathway. So there are multiple pathways to achieve this. So we definitely need more and more renewable for sure. And there is also skepticism in the beginning whether whether grids are can withstand that kind of renewable, or do we need in that. But it has proved beyond a point that there are many countries have already reached beyond 50%, beyond 60%. Still, we are able to meet that. So the technologies, as we are progressing, the technologies also come in, and some of the renewable technologies, like for example the photovoltaic, it used to be a $1 per kilowatt hour not long ago, and with the volume effect and technology evolution, it came less than few cents per kilowatt hour, making it this itself is a business case, and it is fueling the lot of penetration in that. Similarly, there are other technologies which are required for the energy transition, is also evolving it. So we need a multiple technologies and multiple pathways to reach the transition. And I have been saying at least, the challenge of this energy transition is so huge, and it is bigger than I would say one individual, one organization, if I may say so, one country as a whole. What we need is to working together in a collaborative manner, bringing the technologies at a scale and speed that is required for the transition. It is evolving it. As we are evolving, there's a lot of learnings are taking place, and while learning, we are also implementing those learnings as part of our technologies. As a technology provider in India, we are present for the last 75 years. We have 19 manufacturing factories are there, and just give a little bit of how deeply we are engaged in this energy transition journey in India. Eight of the 16 HVDC links in India, which transmit a bulk power, they run through our technology, 8 of the 16. And when we go to the transport sector, every Shatabdi U-board, every Rajdhani U-board, one out of the three is powered through our technology below that in there. So that's where we are. And when it comes to the metro stations, you name any of them, whether it's Delhi, Bangalore, everything, 80% of them, they use our technology in that. And similarly, the renewable today, more than one third of the renewable, they use our technology, manufactured in India and designed in India, and also of one fourth of what we produce here, we export globally for the energy transition. So the technologies are available, but the technology need to scale it up. One good example given my co-panelist is talking about the nuclear. The first time in the recent government has set 100 gigawatt of nuclear by 2047. Not only they said that, but they've also removed the civil nuclear liability, which was a big roadblock for the companies like us to participate in that. That they've removed it, and then they're also talking about the SMR technology. I think we need more of renewable solar and wind for sure. We have a lot of these things are there, but in addition to that, we also need the different technology because we have a long coast, right? We need to also offshore wind. Offshore wind is the one. Right now, the prices may be very high, but once we have the scale, we have the technologies locally made, locally available. I'm sure those things also will come in picture in that. In overall summary is that without the transmission, there is no energy transition. We need to have a basic things in that, and there are many pathways and the many technologies available. The key is how do we bring those technologies locally available at a scale, at a speed that is required for our customers, and it is affordable in India, because that's also an important in that. So that's my summary.
Thank you, Venu. Very interesting. So next time I travel in Shatabdi
Yeah.
or metro, I'll make sure to remember
Absolutely.
Hitachi Energy and thank for that.
Yes.
No, it's interesting that things that all of us do as OEMs or service providers or advisors, when they touch the end customer, people always tend to remember. Like even for EY, whenever I take DigiYatra at the airport, I know that it was done by EY or Aadhaar
Yeah.
based on EY. So similarly, the metro or Shatabdi is a very interesting touch point to remember.
Yeah.
Thank you for sharing that. Let's dive a little deeper now on the topic around transmission. So there are 3-4 challenges that are coming up in the transmission and integration of clean energy in the sector. Challenge one is around the expansion of transmission grids. And what we're seeing is the EPC costs or the availability is going very, very difficult for transmission expansion in the country. At the same point of time, linkage of solar plants at select locations into the main grids are becoming a challenge. So, challenge one is around scaling this up. Challenge two that we're seeing is in terms of the demand spikes that are expected to come up because of EV integration. We plug our car in a regular building electricity, but it's not that it's serviceable directly. And similarly, mega data centers coming up, which will require spiked in electricity demand. Some of it may be serviced by SMR, but a lot of it needs to be integrated into the grid. Second challenge is around demand spikes. Third challenge that we're seeing is around leveraging a lot more of the new AI technologies to make sure we are able to manage and balance the grid, not just for demand spikes, but also for future resource adequacy. And how do we get that into place? The fourth challenge is also around the future skilled workforce to make sure that we have the right people in the room and beyond, to be able to manage and deliver all of this. So we're facing a tons of challenges in transmission and particularly integrating clean energy into the grid. Quick early thoughts from each of you on how should we look to solve these, and maybe CASC and Hitachi is already helping solve these. So how do we do that? So,
So
yes.
if you see from the grid perspective, of course, more than a lakh, 1.5 lakh kilometers of transmission line required, and integration of the state grid as well as the central grid, so that you get through this surcharge, mixed duty, all that, so that
Yes.
the Prime Minister's dream of one country, one power, one price, that will be the backbone to power reaching the end consumer at the most affordable value. Secondly, over and above integrating the whole country, the most second important thing would be decentralization of a lot of units. By decentralization, I mean Gaurav was mentioning, like a data center. Now, like a green ammonia plant. A green ammonia plant cannot afford to go below 20% output. It cannot. A hydrogen plant cannot afford to go below 10% output. They have to run continuously, they have to get continuous power. If you see wind power, it is very unreliable. Solar power, it has its own constraints. So, in the present premises, when the nuclear reactors are still to come, maybe by 2029-30, storage will be the backbone of providing consistent, sustainable, renewable power to any off-taker of any kind of industry. So, and in order to be self-sufficient, which is required, we need to own the whole value chain as India. So, business houses need to set up lithium refineries where they manufacture cathode active material. The government of India is promoting this. Ladies and gentlemen, if you visit the government corridors of Niti Aayog and all, you'd be surprised to see they are 10 miles ahead from any of us private entrepreneurs in their vision, in their thought. I'll just give an example. We approached the Ministry of Mines that we need to set up a lithium refinery wherein we make cathode active material, which is the key to the battery. CAM constitutes 65% of the battery cost. So if you set up refineries in India, at present there are only refineries only in China. So you need the raw material is lithium. So the next step the Ministry of Mines has taken in the last 6 months, they have signed a G2G agreement with Australia, South Africa for securing lithium. Very important. See, lithium exists in two forms, either as a ore or as a kind of brine solution. Brine solutions in Chile or Bolivia, or I as a private entrepreneur, I won't go to Chile and Bolivia to get lithium. But government of India can go. They can sign long-term agreements with governments to acquire, to secure lithium reserves for their refineries being set up in India. Now, once you start making cathode active material, you can supply that material to small battery manufacturers which are building up in India. Once the market matures, this entrepreneur, this business house, which set up a refinery, it can do a backward integration and a forward integration and set up a battery manufacturing plant. This is the first and foremost thing which is required to be done in India in the manufacturing sector. Second, recycling of batteries. We need a lot of business houses to come up for recycling of batteries to get lithium, cobalt, nickel out of these batteries. So that because you will have 150 gigawatt hour of battery storage by 2030 and 450 gigawatt of battery storage by 2047. It's not a joke. And then the amount of batteries coming out for recycling, the amount of metals that can come out, your whole dependency on lithium to a great extent from the external world will reduce. So this is like a holistic 360 approach. When you become self-sufficient, you have a huge amount of battery storage reserve so as to make your grid more consistent, more sustainable. Most important point as far as grid stability is concerned. Coming to AI, I just informed the house, if you put up a query in Google, the answer which comes to you, suppose the power consumed is 1 unit of electricity. You put the same query to ChatGPT, the power consumed is 8 units. More and more you push towards AI, more and more is the power consumption. This will become a very important factor when it comes to assessment of the power requirement in the future. Today, US is targeting 10% of the whole US power consumption to be only consumed by the cloud. That is huge. So with AI coming in, the power requirement will increase and the requirement for consistent sustainable power. So storage is the backbone till the nuclear comes into force.
So storage is the potential
Very
solution.
important. And manufacturing in India.
Yeah.
SMR manufacturing in India, battery manufacturing in India, lithium from out, because we have paucity of lithium reserves. So we can secure lithium reserves across the globe. And off-takers in the form of countries who are hostile to China would be our first getaways.
Thank you, Kush. Let me welcome our panelist, Mr. Pankaj Kumar Pandey. He is an IAS officer. He is also the managing director for Karnataka Power Transmission Corporation Limited, KPTCL. So welcome, to the stage. Just to bring you up to speed, we are discussing two aspects. Aspect one is around how energy transition is building up in India, and in that context, how power transmission needs to ensure that it integrates all of the solar, the wind, SMR availability into the grid. And the third aspect, which in fact you may be leading directly in Karnataka, given Bangalore being there, is how mega data centers, AI, and their increasing energy requirements, how do we cater to that and provide the transmission connectivity? So maybe just some starting thoughts from you on the topic, and then we can delve deeper.
Thank you very much, and my apologies for being late. Incidentally, there was a VC video conference by Ministry of Power on a very complicated but extremely important subject of taking out transmission lines, overhead transmission lines across the fields, across urban pockets, and all that. And that is where we have the Achilles heel, or the biggest problem which we have. And there's a lot of thought process churning going on how do we fix the right value for the land which the farmer doesn't perennially lose, but actually he is not able to make use of that land. And the problem is extremely difficult in pockets like Mumbai, Bangalore, Chennai, around in and around urban areas. So just got over, and I came. Now, just to give you the context of Karnataka, and I think the other states are no different from us. See, we had a severe shortage of power last year, the entire country, because of drought in certain areas, and Karnataka and other southern states faced that. So in August we had uh, 2023 August we had peak loads which were greater than our historical peak load, and that is say in the height of monsoon. So this was the shortage and the extent of the shortage, and then obviously post-COVID recovery, and there was a lot of industrial growth which came. Now this woke all of us from the slumber that yes, we have to plan on a much bigger scale, and then we had to do a lot of brainwashing of our transmission engineers and the planners, saying that you please come out of your thought process of doing X number of substations every year. It is not like that. And then the state government came out with its budget announcement also as well, that what we have at present, around 35 gigawatts of installed capacity in the state, will be made 60 gigawatts, which will be doubled in the next 5 years. So by 2030, that's the announcement which was put in the budget, so that everyone works towards that. And the transmission capacity, which is right now 30 gigawatts at the 220 kV bus level, on which we get the tariff from the Electricity Regulatory Commission, that has to also double, or slightly more than that, because we are a RE rich state, and our transmission lines at many places may not be used in the night unless until we get a storage and all that. So that fact was brought, and now everyone has aligned to the fact that whatever transmission capacity we have to almost double that, or slightly more than that. And in that context, we have to plan a massive network upgradation. And in that process, obviously, the things which are important are other finances, the right of the way on which we were discussing, and certain other factors. And obviously, the solutions is in terms of TBCB. You come out with private players to help us. Similarly, the state transmission companies push for the connectivity down the line and all those things. Two, three thoughts which I will leave with you. One is that when we plan for the substations like 400 kV, 765, 220 kV substations, it will be worthwhile to take more land to set up a solar, say, the core of the station land, you take it on the land acquisition. But the remaining land, you can take it primarily on the lease and set up a solar plant close to that, along with a small battery or supported battery, so that you have, one is the ease of getting the land from the farmers, because they will have a continuous source of revenue coming from the solar plant which you put near the substation, and your process of acquiring the land becomes much easier. The second is that in the areas which are closer to the city, where the guidance value has not reached the stage or has not reached to the practical value, you need to then practically fix the values for the right of way for the land as well. Rightly said by the panelists that now in the coming days and years, the core will be the RE, your solar, wind, hydel wherever the capacity is still left, plus the storage, your battery and the pump storage. Pump storage obviously have a longer gestation period, but probably certain pump storages where we can use abandoned mines which have a storage available with them. We have lot of abandoned quarries and mines which are there in Karnataka, and lot of other states also will have, and they have a ready-made water storage which is available, and probably we can combine the geography of the place to come out with a mini pump storage plant, and those obviously will take little lesser time compared to the mega pump storage plants. So distributed pump storage plants using abandoned mines can be one solution of doing it faster, and that will also help us in having distributed pump storages, and obviously the battery storage at the transmission element and at the generation element both. I'll suggest both, because transmission element that will defer your investment in the transmission, or wherever you have congestion you will be able to remove that. So I see that this is going to contribute to majority of our future plans in the sector.
Thank you, Pankaji. It's interesting that whenever I have moderated with an IAS officer, they come up with perspectives far beyond in terms of the whole ecosystem, how it should operate, versus just what they need to do. And I think that clearly adds value in nation building. Thank you for sharing that.
Thank you.
Venu, coming to you in terms of how the technology is evolving to provide for this clean energy transmission integration, high voltage, low voltage, ensuring the grid connectivity happens correctly. In case Hitachi Energy is also working on the AI aspects of it, how do we leverage technology? And you spoke about indigenously developed, even though Hitachi Energy is a global brand. So tell us a little more about that.
Yeah, sure. I think before I come here, your previous question, if I can
Yes.
bucket two of them, you talked about the demand, and you talked about also one is the demand of energy is going up, and then to cater those demand, the OEM perspective or developers perspective, how they are also catering is also extremely important in that. So when the sudden demand spikes up naturally, you'll not overnight you can't set up the factories, and as a global company, we'll always use the flexible source manufacturing from other factories and bring it, but it is not possible to do that. So what we have seen in other parts of the world, that this demand spike is there in every part of the world in the energy transition, to ensure that the grids are very robust and secure and flexible to take care of the renewable and also electrify anything and everything. And they have approached what I call is a project based to a program based approach. What does it mean? Basically is that we have always we tender a one particular project, we engineer it, and we execute it, and the second project comes, once again we do the same thing, the cycle after the cycle. With that, what happening is that we are repeating many times same thing, or we are doing same thing again and again and again for that. And you cannot, in this kind of demand cycle, you will not able to put your resources for that, because today, like our like our boundaries are blurred, right? We are a global economy. Similarly, our workforce is also a global workforce. Today, for example, we have almost close to 9,000 employees here, and half of that they do around the world project, anything and everything, including a bids, including the engineering, including the commissioning. You have a commissioning requirement, person goes from here and do that. So like that, many other companies also be doing it. Since the workforce is a global, so we will not wait for a demand coming from one customer or one country, something like that. So that's the reason we need to move away from this approach and do one time you order and one time engineer and execute 5 times, 6 times, or whatever way it allows that. That way you have a lot of benefits, lot of synergies. Cost also will come down, and it make more accessible the technologies for our customers in that. This is what we have seen. And the second, which you talked about, the energy efficiency itself, which you have given a AI. What I agree with what Kush talking about, AI, because I have been to one of the AI ready data center in Singapore very recently. It's absolutely, I could see put a chat GPT query, you see that. But then we also seen after that deep seek intervention, right? So it is not 10 times, it is everything is evolving it, right? As we are evolving, we're also doing it. Definitely not going to be 9 to 10 times going forward, but it's not going to be the same thing. Somewhere in between, there's a lot of, on the AI side also has to happen, but then companies like also we are looking at optimizing the energy needs for the data center. How do we, distribute so that, we are bringing down the total thing. Both sides has to happen. Somewhere we do that. So that's the first and foremost. Coming back to your second point, Gaurav, on the technologies, as I said, there are many pathways to reach the transition. For example, India is a country has set a very highly ambitious target of 2030, that is 500 gigawatt of renewable by 2030, 500 gigawatt of interstate transmission networks built by 2030, and 5 million tons of green ammonia production. So these targets are so huge. If you want to achieve those targets, even if you give a factor of it, then country as a whole, we need to do 2 to 3 times more than what we have been doing it. And that cannot happen with the same kind of technology. We need all the technologies have come in that. We need the storage, we need the first of all transmission technology, localized technology we need so that we are able to supply at the cost required by our customers, because affordability is important. We cannot bring the same thing and benchmark with from a European standards, and the transmission cost will be so high. Ultimately, then it will not viable for our last mile connecting customers, right? And then we also need the storage solutions, both battery as well as pumped hydro. Right now, the battery prices are higher, but with a lot of push from the government, especially on recent budget, they allowed a lot of custom duty waiver on the cobalt and other things, will help to fuel the growth of these battery manufacturing here locally, and that would fuel the growth of the pumped hydro storage. We need the transmission, we need the storage, I need various generations to come in that. The technologies are there right now to do that. We need to start what we have it, but we also look forward to the newer technologies.
Thank you, Venu. Um, Pankaj, I'll come to you and then back to you, Kush, soon after. Traffic in metros is notorious, whether it's Delhi or it's Bangalore. But companies like KPTCL or CESC are tasked with creating those transmission highways to make sure all the electricity reaches where it needs to reach. And you spoke about the downtime currently, but you also spoke about 2x growth required in transmission capacities. We have not just domestic audience, but also international audience with us today. What is your message to the audience and the entrepreneurs who are setting up shop in Karnataka and beyond, in southern India, on how we will make sure we make that happen for their comfort, that yes, they can focus on the business and these aspects are taken care of? Linked to that, while you answer, a lot of the global majors are setting up shop, particularly in your region, and they have their own net zero requirements, decarbonization, and clean energy requirements. So, first, how to make sure the transmission highways come up sufficiently, and second, within that, how do we give the comfort to them that yes, you're receiving clean power and we're integrating all of it?
Yeah. So all these are interlinked to each other. So I try to answer. So one is in terms of sufficiency of the transmission, say capacity which we have. We have, in fact, Bangalore and in around Bangalore is the major consumption center. And we have the RE generation, which happens typically in the northern part of Karnataka, which is a Belgaum, Bijapur, Bagalkot, Bidar, that northern part of the state, which generates huge amount of solar. Now, just to give you a perspective, right now we have around 62 to 63% of our power in the state, which is coming from the renewable energy, RE. And this is going to touch almost 70 to 72% after we make it double the capacity and all that. And to handle that, what we are trying to do is we are trying to protect our present right of way, upgrade the conductor, go for a better capacity of tower, unipole, all those, or go for a higher tower and all those things, and have a higher performance conductor HPC. When we are planning at this stage, in fact, yesterday we had a meeting of our organization of our engineers, and we have a technical advisory committee. We have got a lot of experts from the transmission field, and we told that, see, when we are planning, we should have 10 years in mind, and therefore don't start with the 20 MVA into 2 or 30 MVA into 2 or 41.5 MVA into 2. You go for the max capacity for the transformer, because once we are building it, or for the lines also, because once you are building it, you are not going to touch it again, or it will be very difficult again to change the capacity and increase the capacity, and therefore go for the higher capacity. This will not be sufficient, and therefore you have to come out from the mentality of planning only for the next 2 3 years. It is next 10 years planning, and we have a lot of new lines, right of ways, which are going to come up under the tariff based competitive bidding. A lot of substations have been planned. Just to give you a perspective, we have right now 9 substations of 400 kV for the entire state, apart from what PGCIL has. This is KPTCL substations, and 7 works are ongoing. Another almost 20 or 15 substations, 15 400 kV substations have been planned. So the 15 plus 7, 22. So we are going to almost double or add 2 numbers of the substation, twice the number of the substations of 400 kV which we have, and most of them will be coming in and around Bangalore. Then try to secure the city with a 400 kV ring. With a lot of automation, we are trying to introduce into the transmission elements to identify for the maintenance and all those aspects, your drone monitoring, your other kinds of monitorings which are there. So that we are trying to assure. Bangalore being Bangalore, in terms of requirement of data centers, in terms of requirement of the industries, and all those we are trying to create systems which will shield them from any kind of problems which may come in the future. Data centers, in fact, we are planning to identify certain pieces of land which we have in the city, where we have air insulated substations. Probably we can monetize, get the data center next to the substation. Assurance of power is there in N-1 criteria or N-2 criteria. At a few places we are going, so that we have double redundancy rather than having a single redundancy in terms of the surety of the power supply. So all those aspects we are putting there, and we know that what Bangalore today consumes around 4,500 megawatt or so, that may double very easily, and that will happen.
Excellent. Thank you so much, Pankaji. That was very useful perspective. Coming to you, Kush, similar question on the eastern part of the country, which is growing very rapidly on all aspects of power requirements. How is CAC catering to that?
So, as the house knows, we've been supplying power to Calcutta since umpteen number of years.
Yes.
The sole private company, and uh, the biggest initiative and challenge which all the distribution franchisees have is, first is reduction of loss. And with the privatization of distribution in the country, it has come as a big boom to the country, because cities which had losses to the order of 28%, 30%, Calcutta, we are proud to announce, we are below 7%. It's a global standard.
Wow.
And the same we are targeting for almost all the 9 franchises we have. There are challenges. There are demographic challenges. There are infrastructure challenges. Like we are in Malegaon. All the conductors are bare conductors. Any amount of smart meter, and I'll tell the house, the best of smart meters are tampered, you cannot believe. So the kind of expertise people have in tampering meters, it's like I wanted to meet 2 of these tamperers, and I want to learn from them. Like these are people who have brains here to tamper meters. Then you have to get the remedial measures so that they won't tamper again. So it's a challenge for a distribution company on a day-to-day basis. Of course, putting up smart, like right now in almost all the cities, they are going for rooftop solars. Now, rooftop solars with net metering, it is one thing which is integrating into the system, which is a big challenge, because Then your whole smart grid concept, introduction of AIs and the latest tools, and the infrastructure build up in the form of all the gadgets, all the monitoring gadgets required, AI to be used for predictive maintenance so that your sudden like loss of power is almost like nullified. All risks amounting to loss in power suddenly is mitigated. Chances of blackouts are mitigated on account of grid constraints. So all this has become an integral part of a licensee or a franchisee's day-to-day activity. So, and technology is coming. So, if we do not acquire technology, state-of-art systems, we won't survive. So, if we construct any amount of kilometers of transmission line and substations and whatever we do, a whole integrated approach wherein we plug every area that is to be addressed, so that the consumer, end consumer, all the end factory, all the end off taker gets consistent, sustainable, reliable power. That's the call of the day, or else we will not grow at all. So if you want to see a developed India by 2047, we need to plug every hole and address every aspect: generation, distribution, transmission, getting into manufacturing, being self-sufficient, tying up all raw material which is not in India. Now they have, earlier it was ALMM for module manufacturing. Now they have come with ALCM. So there's approved list of cell manufacturers. You hardly have 10 gigawatt of cell manufacturing in the country. By 26, if you do not buy a cell manufactured in India, your solar plant won't get a license. And we have shortage of silica sand good enough to manufacture cells and modules. So Indonesia has opened up now for giving concessions for silica. So we are on the process of acquiring silica reserves in Indonesia, set up a polysilicon plant there, and develop wafers there, and bring the wafers on a zero duty FTA advantage to India, and then set up wafer to cell and cell to module. So adapting to the time and becoming self-sufficient with respect to manufacturing will be the backbone. And especially setting up a polysilicon factory outside India is favorable, because it amount 40% of the cost of polysilicon is the cost of power. So it will only add to the power requirement in the country. So better put it in Indonesia or in places where the silica reserve is there, and there's no point bringing so much of silica to India and getting like taxed on freight and all. So this is one more initiative which is being taken to become self-sufficient, and that's how in an integrated way the country will progress.
Thank you, Kush. So I think maybe we need to plan for a hackathon on tampering, or maybe a tampathon of kinds. But very interesting perspectives from the panelists today. Kush spoke about not just solar, wind, and other forms of new energies, but also coal gasification, which can cost one fourth of the usual syngas costs, or SMR, small modular nuclear reactors, which can really propagate and propel our future requirements. Venu spoke about the need for technology and how technology is evolving very, very fast to cater to all the clean energy requirements in transmission in the country, and indigenous at that with Hitachi Energy. And Pankaj spoke about how we need to bring the whole ecosystem together to make sure this actually works out, and in particular, how Karnataka Power Transmission is actually getting fiercely ready to cater to all the increasing energy requirements in the country. So, very interesting perspectives. Thank you, panelists.